It's 8 o'clock. 21 participants are there.
Can start it.
Shall we start?
Yeah.
Recording in progress.
Good evening, everybody. Welcome to this edition of Isgk Masterclass. And this is a special class on research methodology. We had a session earlier. We had multiple sessions earlier. And today's faculty is none other than Professor Narendra Nathan, who is well known to you. Professor Narendra Nathan has taken class for you earlier. The last class was on risk factors, NAFL, and that was well received. Professor Narendra is the former professor and head of gastroenterology of Government Medical College, Thiruvananthapuram, and he is also the director of the PIDE cell, which is dealing with the epidemiology and prevention of diseases. So at the moment is senior consultant at Cosmopolitan Hospital and GG Hospital, Thiruvananthapuram. Welcome, sir. And to moderate today's session, we have a senior person, Professor Jayanti, who is well known to all of the students. And in fact, she was requesting repeatedly to have research methodology sessions because research methodology sessions are very useful. And most of the students and faculty are also ignorant. And sometimes even theory questions come. And during clinics also, sometimes some examiners ask research methodology questions. And the students somehow feel it very difficult to wriggle out of that difficult scenario. And Narendra sir has the ability to make even the hard nut to make like a simple thing. I would say he is able to make like if there's some subject like concrete, which is too hard to break. But Narendra sir will make it like a very tasty ice cream soft. Okay, so he has such a capability to describe statistical things in such a simple language, which even an ordinary person will understand very well. So, a warm welcome once again, Narendran sir. And for today's session, we have lined up second years, Dr. Parath from SIMS Chennai, Dr. Rajendra Prasad Global Chennai, Dr. Sumukha MM Chennai, Dr. Jovita Preeti from Medical Trust Kochi, Dr. Sai Kiranmai from Master MIMS Kozhikode, and Dr. Jerry Abraham Joseph, BPS Lakeshore Kochi. And with these words, I hand over to Jayanti ma'am.
Good evening to all, and Dr. Beach has already given a beautiful introduction. I'll also be listening because I love learning, At this age, I'm not able to practice research, at least the statistics bit, but as Dr. VT mentioned, sir, last time also we enjoyed this session, sir. So I'll be more of a listener, learning from you, sir. Over to you, sir.
You are not audible, sir. You are not audible.
We can't hear you. You're muted. No. We can't still hear you, sir. You're unmuted, but we can't hear you. Maybe the volume is low.
Sir, can you check the audio side of your computer, right lower panel? Whether it is in off mode or something. That's all maximum volume.
Something is coming as off. That's off, sir. The headphone is off. Someone can help, sir.
Hello. Can you?
Yes, sir. Yes, sir. You are audible.
Sorry, I'm sorry for the all the.
You're audible, sir.
Yeah. Is my screen sharing working?
Yeah.
You can see my screen.
Full screen, sir. Full screen.
Okay, thanks a lot. Thank you. So let us. So welcome you all to another session on research methodology. So the objectives of this session, what I thought was I would just discuss some design strategies, the characteristics of some designs, some small discussion about sample size, the errors in statistical inference, about bias, how to interpret the results, and a small recap. But you all know the latent objective of any session on research methodology is how to critique a journal article or how to, we are bombarded with journal articles, and it is for us to separate what is the chaff and what is the grain. So to choose the grain out of the chaff, we require some background of research methodology, and that's what I'm going to try to achieve. So now, you know that to maximize the benefit to society, it is not enough that you do research, but you should do it. It's not enough that you do research, but you should do it well. So now, remember that the most important and the hardest part of doing research is coming up with a good research question or coming up with a good hypothesis. And once you have got a good research question, and if you think that it is good, you can always, research methodology comes in next, and you can always go up and read the journals how such questions have been dealt with, and thereafter it becomes easy. So the hardest part of doing research is coming out with a good question and a good hypothesis. So what we do is that once you have got a hypothesis or a question, we test the hypothesis by a study design, and it is a design which directs how the study is done and the strength of evidence that is produced. And we know that the time constraints, the economic constraints, all will decide what design that we choose. And one thing which all postgraduates should know is that research not worth publishing is not worth doing. If you think that your research, as long as you read the article and you think that it's not worth publishing, I don't think that you should go ahead and do the research further. So research not worth publishing is not worth doing. That's what I would like to say. So now let's go straight to epidemiological study designs. We know that there are descriptive studies where we describe the frequency of disease and collect the data on frequencies, and then we do an analysis, test a causal hypothesis, test how a diagnosis is made, how we can predict prognosis. So analytical studies, what are the risk factors of a disease? These are the things we study by analytic studies, and then experimental studies where we design an experiment mainly to study the effect of an intervention. So these are the basic study designs. And going to descriptive studies, it can be either a case report, case series, cross-sectional studies, or ecological studies as it is called. And if you look at the gastroenterology scene in India, case series. If you know the case series, anyone can tell me what this case series is about? We have got any postgraduate students there?
Yes, sir. All of them.
Anyone can. I think if who is there? Who is?
Acomelia, sir.
Who is there?
Acomelia.
Yeah, but due to thalidomide. So case series are there important, their place. What about this case series? Can anyone tell me what this is about? Pneumocystis. The first report of, what is it? The first report of pneumocystic pneumonia, mucosal candidiasis in a healthy homosexual man. Evidence of a new acquired cellular immunodeficiency. This is the first report of AIDS. HIV/AIDS, very good. And you know that if you look at India, there are a number of good case series have been reported. You know about the tropical sprue reported by Baker and Martin. ITMS, as it was called from Delhi, B.N. Tandon and colleagues, idiopathic tropical malabsorption syndrome. The number about the tropical pancreatitis described by Professor Giorgi, Spicciolini, and others. The ultra-constrictive disease of the intestine described by S.D. Tandon. Non-A, non-B hepatitis described by Kuru. And others. Non-cirrhotic portal fibrosis described by Sama and his colleagues. And toxic hepatitis described from Rajasthan, an epidemic of toxic hepatitis described from Rajasthan, an epidemic of veno-occlusive disease described from Madhya Pradesh. So case series have got a real place in the literature, and these are all landmark publications, landmark studies, which opened a new area of research. And so case series are their place. You should know that the case series are the most basic descriptive study. It is a link between clinical medicine and epidemiology. You can generate an hypothesis, but rarely the evidence can be strong, when you have a case series. Now coming to cross-sectional studies, these are observational studies. You can do a cross-sectional study at different points in time. And you can decide, you can describe variable like the transaminase levels or the height of the person, the weight of people. So cross-sectional studies helps us to describe things. Usually we do not test a hypothesis by cross-sectional studies. Can one postgraduate please stand up and say, what term is this one? Which skew is this one? Can anyone?
Dr. Para, seems Chennai.
What is this? Which way is it skewed?
It's left skewed, sir.
Pardon?
Left skewed, sir.
Left skewed. Okay. So the typical, this is the distribution of ALT, AST levels. This does not follow a bell-shaped curve, but is skewed with a long tail at higher values. Now, there was a statistician in US who told us that many times you may get confused whether it is left or right skewed. So he said that just imagine that this is like a fish, and that the fish head is here and the tail is there. And and where the tail is, that is the way it is skewed. So this is, which skew is this one?
Right skew.
Right skewed.
Right skewed, yeah, right skewed, yes. That's what you said, is it? So this is a right skewed one. So that's about the skew distribution. And now, when you look at the prevalence, like the description, cross-sectional study, this was a paper published in the Indian Journal of Medical Research, 75 authors, and it gave us a very good idea about the impact, the burden of the disease of COVID at that time. So cross-sectional studies have their role. But let me they give us the incidence and prevalence. Can I have one student answering this? Suppose in this crowd there are 100 people, and in this crowd there are 20 bald men. So 20 is what? 20 is the
Rajendra Prasad.
Yes, sir. 20 is the prevalence.
Prevalence, very good. So I think 20 is the prevalence. So what I do is that I follow the same people, and after 1 year I find that there are 40 bald men. So what is it? So how much is the incidence? So there are in the next 1 year 20. How much is the incidence?
40.
20.
20, is it? No, you know that there were 100 people and 20 were bald. 80 were not bald. It is these 80% of the 80 people who develop baldness. The person who is already bald does not develop baldness. So incidence is the occurrence of a disease in a person who does not have that condition of interest. So what is the percentage of incidence? What is the incidence?
50%, sir.
No, I think that 100 people were there and 20 were bald. 80 are without baldness. Among this 80, totally there are 40 bald men. So among this 80, 20 developed baldness. 20 were already there.
25%, sir.
25%. Is it clear? I don't know whether I confused the issue. So 100 out of 100 people, there are 20 bald people. And after 1 year, I saw that there are again 20 additional people have become bald. So total becomes 40. But these 20 additional people were from the 80 people who are not bald. So 20 is actually 25%. I hope it's clear.
Yes.
That is incidence and prevalence. Some people say that the difference between a clinician and a clinical epidemiologist is that they know the difference between incidence and prevalence.
Sir,
Now,
can I interrupt, sir?
yeah,
In our community medicine teaching, it is told the occurrence of new cases
yeah.
for a particular condition for a predefined time, that is considered as the incidence, and occurrence of the disease in a cross-sectional study at any point of time is called the prevalence.
That's true.
Is it the same?
Yeah, same thing. No, and the disease occurs only in people who did not have the disease.
Okay, that's the most important thing.
That's and the incidence occurs in people who do not have the disease. So I think this is another cross-sectional study. The association between this was a study which was done in the Hunan province, in Henan province in China, where they took different places where the salts were sold. Look at here the salts sold per kilogram per person per year. And here they looked at their death rate per 100,000 due to carcinoma esophagus. And they came to the conclusion that as the salt intake increases, the death due to carcinoma increases. These types of studies, where you look at the ecological exposure, this type of studies are called as ecological study or correlational studies. Now let me come to another. Now this is an ecological COVID-19 and air pollution. Look at the counts of deaths from COVID-19, and here is the particulate matter in the percentage particulate matter. As particulate matter increases, the mortality also increases. This is also an ecological study. But one of the things we have to know from ecological studies is that association does not mean causation. When you talk about ecological study, this paper by Emil Durkheim has been hailed as one of the excellent studies on suicide. Emil Durkheim said that, if you look at it, he concluded that social control, the areas where there are more Catholics, he found that the suicide rates were low. So the study was done in Europe. They looked at different populations and found that wherever there are more Catholics, the suicide rates were low. So he concluded that social controls within the Catholic religion reduce the likelihood of Catholics taking their own lives. But this study has been, and all such ecological studies has been criticized because of the thing called as ecological fallacy. We do not know the people who committed suicide were actually Catholics or not. And I think that similarly, suppose I do a study of traffic accidents in India. It has been said that 90% of the traffic accidents are caused by male drivers, and only 10% of the traffic accidents are by female drivers. Does it mean that if you want a good driver, would you hire a male or would you hire a female? But this is what is called as ecological fallacy, interpretation of statistical data, where inferences about the nature of individuals are deduced from inference of a group. So this is ecological fallacy. So now let us take this issue. Can I have another person to address this? Whenever there is a fire, what is the relationship between the people who get injured and the number of firefighters? What would be the relationship between the two?
Dr. Samuha, Triple M Chennai.
Yeah. Can you follow me? In the case of a fire, what is the relationship between the number of people injured and the number of firefighters available? What do you expect it to be, or what is it usually?
If Dr. Suma is not there, Dr. Jovida Preeti. Dr. Jovida, are you there?
Yes, sir.
Yeah, what do you expect the team? What do you expect the number of people injured and the number of firefighters there? What is the relationship between them? Do you think that the more the firefighters, the more injured, or more the firefighters, less people are injured?
More firefighters, less people are injured.
That's what we expect. That's what actually, but in this study, what they found was that the more the firefighters, the more people are getting injured. You know that this is the correlation. You know the correlation is expressed as R 0.65 or plus 0.65 means that there is a positive correlation. The more the firefighters, the more people are getting injured. So you know that if the correlation coefficient is 1, then it's perfect correlation between the two variables. And if it is 0, there is no correlation between the two variables. So what do we do? So I think that here the lady is shouting against the person, and he says that correlation does not imply causation. So what do you do when you get a study? You expect that the more firefighters, the less should be the injured. But when I took the aggregate data, this is what I get. So how can we, what have actually went wrong there? Or how can we solve that problem?
Dr. Sumuga, are you there?
Yes, sir.
Did you get my question? Yeah. Because,
Yes, sir.
yeah, so what can we do about it? No, what these people did was that they divided this fire into 3 different groups. Mild, the intensity of the fire, mild, moderate, and very high, very severe. And when they analyzed it separately, they found that the correlation between the firefighters and the injured people was actually negative. So this was another variable which actually interfered with our inferences. So when we interpret it, dividing people into different severity, then as our PG has suggested, there is an inverse correlation between the firefighters and injured people. So one of the things in correlational studies is that the association does not mean causation. So I think now let's go to analytical studies. One of the most important things in analysis is that epidemiological conclusions cannot be drawn purely from clinical data of the sick people seen. So if you just look at the people with fatty liver disease and say that their average BMI is 25, doesn't mean anything unless you know what is the BMI of the other people. So usually epidemiological conclusions cannot be drawn purely from clinical data or of the sick people that we have seen. So now we have just discussed the descriptive study and analytical studies. We'll just go through case control and cohort studies. This is a study which we did about almost 3 decades ago. Those days, reusable needles were widely used, and we did a case control study to find out whether reusable needles were a major risk factor for acute hepatitis. Our study showed that it was. The odds ratio was 3.9 with a 95% confidence interval 2 to 7.3. So what I would like to say here is that in a case control study, what we do is that we have patients with the disease. You can see the persons with the disease, and you take controls without the disease, and you look back and see the exposure. If it is cancer and smoking, you see from the cancer patients, you see how many smoked. If it is the patients with acute hepatitis, see how many were exposed to reusable needles. Again, for the same control group, you see how many were smoking, and then compare the 2 groups and come with what is the values which are actually the odds ratios. So these are the case control. These are case control studies are done. So, but you can commit mistake whenever you do a study, and when you reach an inference, you can commit a mistake, and this is what we call as an error. Error refers to a mistaken result obtained from a study or an experiment. These errors can be either random error or a systematic error. I will go into it a little detail later on. A random error is a deviation of the sample value from the population mean due to chance. Because in the population, if you find that people with acute hepatitis are more exposed to reusable needles, and in your samples, you may find that that's not the case. This is an error. And this is a random error, and this is due to a sample value. This is due to a sampling error. And there are 2 types of random errors, the alpha error and the beta error, or the type 1 and type 2. I will go into it a little later. And or it can be a systematic error. Systematic error may be that there is an error in measurement, or an error in the sampling of the people or the controls, and there you may commit a mistake. So it's called the sampling error, or the measurement error, or it may be confounding. But we have discussed confounding in detail last time. I'm not going into it detail now. So let us come back to the random error. If there is any doubt, Dr. Jayanti, you can please you can interfere and tell me whether I should clarify certain points specifically. So let us assume that whenever I did this, I did a study on reusable needles in acute hepatitis and compared them with people who didn't have hepatitis. So I can assume that the two people are, the exposure in the two groups are the same. This is what is called the null hypothesis. Or I have an alternate hypothesis called the, or they are different. Why we have a null hypothesis and the alternate hypothesis is that our knowledge grows by falsifying hypothesis. Suppose Mr. X is a honest man. Everyone thinks that he's honest man, not because that he has been proved to be honest, because it has not been, that statement that he is an honest man has not been falsified. Suppose you think that all the crows in the world are black. It's very difficult to prove it, but you can disprove it if you find a black crow. So I think we usually have a hypothesis, a null hypothesis and the alternate hypothesis. Random error is one, it's called as a type 1 error, where you reach a false positive conclusion. That is, let us assume that there is no relationship between smoking and cancer, but you reach a conclusion saying that there is a relationship, and this is what is called as a type 1 error or false positive error. And there is a relationship between smoking and cancer, but you reach a conclusion saying that there is no relationship, and this is what is called as a type 2 error or false negative conclusion. So this is a type 1 error. You're pregnant, he says that. No, it's a false positive error. That is type 1 error. You're not pregnant. This is type 2 error. I hope I've made myself clear what is type 1 error and what is type 2 error. Type 1 is reaching a false positive conclusion, and type 2 is reaching a false negative conclusion. So when you say that my test has a 95% confidence level in avoiding a type 1 error, means that I will make a mistake by chance only about 5% of the time. So if I got a 95% confidence that I don't make a type 1 error, that the chance of my making a type 1 error is only 5%. So if I get type 2 error, 80% is usually the power taken to avoid a type 2 error. 80% power means that the difference that I can assess the difference that I have assumed with a p-value of less than 80% power means that there's 80% chance of ending up with a p-value of less than 0.5 if there really was an important difference between the groups. Let me pose a question. Let us see that there is a hypothesis that male gynecologists earn more than female gynecologists. Let us say that. You want to find out their income. And you find that one person wants to find out, says that even if the difference is 1,000 rupees, he will say that one person is earning more. Whereas another researcher thinks that 1,000 is a small amount. Let us take it as 10,000. Who requires a bigger sample size? Can someone answer that?
Dr. Sai Kiranmai.
If you want to find out a small difference or to find out a big difference, what do you, where do you want to?
The person, one with a 10,000 difference need the bigger sample size.
You can switch on your video also.
Is it?
Please repeat your answer. It was not audible well.
The one with the samples requiring 10,000 difference requires a more sample size.
No, I think, to find out a small difference, a significant difference, which is very small, no, it is not, you require a very, very large sample size. So if you are happy to find out a difference, if you say that if the mean income between the two groups is 10,000, I will take it as significant. You require only a smaller sample size. To find small differences, you require big sample sizes. So it is you are the person who is going to decide what is the difference that you want to find out. I hope I am making myself clear.
Yes.
Clear. To find out the difference between two groups, and if you want to find out small differences, you want a big sample size. Whereas if you want a large difference, then you want a smaller sample size. I don't know whether I think
Sir, I will say what I understood, I will repeat because the students are hesitant to come out. So if the difference shown to be shown is small unit, you require a large sample size.
That's it. Yeah.
Okay.
Yeah, that's it.
Consider it significant. Okay.
Yeah, that is it. So to find out very small differences significant, you require a very, very large sample size. So how do we estimate the sample size? Now, if we can go into the now this is a AP-Info is a software which this is freely available in the CDC, and I suggest that if you are really interested in research, please download this and keep it with you, and you can easily estimate the sample size as I will be demonstrating it now. Okay. Now this is the AP-Info software. You see whether the file is coming up. The hyperlink file, is it showing? Is it showing? Hello?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Well, we go to the practice calculation to get, let's say that I am doing an unmatched case control study. To go to the case control study, this is the thing that you get. So the confidence interval, to get, how much do we take confidence interval if you want a p-value of not 5 or 5% error? 95%. How much is the power that we usually take?
80%.
Suppose I am doing a case control study, and how much cases, usually what is the case and control that we take? How much case and how much control? 1:1.
1:1.
1:1. Let us say that I am doing the study on reusable needles, and I think that the exposure in the population will be 30%. And the odds ratio that I am going to find out, let's say, is 2. So you find the sample size here. This is the sample size. If I want to find out the odds ratio of 2, this is the sample size. Can I ask you one question? Suppose the odds ratio is 3, what will happen to the sample size? I want to find out a bigger, what it means, will it be smaller than this or bigger than that?
Smaller.
Yeah, let us see whether, see that it is smaller than that. So suppose I am doing a study with a disease which is not very common, not very rare. So is there any method that I can, so let us say that this is 1 and I am taking 2 as this, 141. So I am doing a study with, let's say, pancreatitis, and I won't get 140 cases. So is there any method by which I can reduce the sample size? So one of the things you can do with the sample size is to take more controls per case. Suppose with 1 case and 1 control, you are getting 142 cases. Suppose I take 2 cases. See, it comes down to 104. Suppose I case, for every 1 case, I take 3 controls. See, it comes down to 91. Am I clear?
Yes, sir.
Yes, sir.
Yeah, that's, I think that's one of the. So that's, so I would suggest that if you are interested, please download this software and keep it with you. It will be useful for you. Okay.
It's free of cost, no?
It's free of cost. Yeah, it's free. It's free. CDC.
Okay, sir.
So I think it is Isgk is a famous epidemiologist who said that samples which are too small can prove nothing. Samples which are too large can prove anything. So that's what I think. This is something which we can remember when we talk about sample size. What I wanted to stress here is what is an alpha error, what is a beta error, and how we use those false positive and false negative things to estimate the sample size and how we come out with the sample size. If I have not confused you, I think I have succeeded in my presentation. Now let us take the issue. Pardon? Now let us take Covishield and Covaxin. It has been said that Covishield is up to 90% effective and Covaxin is 78 to 81% effective. Now you get a study saying that both Covaxin and Covishield are equally effective. As a student of research methodology, what is the thing that you are worried about? Are they committing an error? What is the thing that you are worried about?
Dr. Jerry?
There is no, they are thinking that there is no, even though there is a difference, they are saying that there is no difference. So this is a false negative report. Pardon? What error is this one?
Beta.
Dr. Jerry, are you there?
Beta error. It's a type 2 errors.
Yeah, very good. This is Is it a beta error? That's what. So whenever you don't find a difference, you have to look into the paper and see, is it a beta error? Do they have sufficient sample size? This is what, whenever you find that there is no difference between two medicines, one of the things you have to look at is the sample size okay? Is it a beta error? That's what you have to look in. Type 2 error. Now, another important thing is that there are many biosimilars. People come out with the adalimumab and things like that. They come out and say that we are, and they may even approach you to do a study on with a biosimilar, and they may come and tell you that both are the same. They are, there is a non-superiority trial, and there is that adalimumab which is available in the market is as good as their biosimilar. In this one, what is the thing that you should look at? When they find that there is no difference, these are the same thing. Whenever there is am I clear in this one? When people approach you to do a study, to say that the biosimilar that have come out is as good as adalimumab, you have to know whether the sample size is adequate to fix up the difference and whether you are committing a beta error. I hope I have made myself clear.
Yes, sir.
Yes, sir.
Thank you. Now this is what is the diagnosis? Anyone? What is the diagnosis here?
Parag?
Chronic calcific pancreatitis.
Calcific pancreatitis.
Pancreatitis. What is this one? Do you know anyone? Does anyone know what this is? Does anyone? I think this is the tapioca or cassava. Yeah? Okay. So I think this is one of the studies that we did. Is cassava a risk factor for pancreatitis? So what we did was that we did this study was published. So what we did was that we compared with age and sex matched healthy hospital visitors. So we did the study of hospital. There are a number of bias which you can get into when you do the studies in a hospital. Let me take another example. Two persons from Bengal. There are a number of people from Bengal, and in Kerala they call them as Bengalis. So in Bengal, there are two people from Bengal as reported to the gastroenterology department. I am doing a study on whether cassava is a risk factor for pancreatitis. Well, cassava is not available in Bengal. One of this person has got pancreatitis, and the other person don't have pancreatitis. So can I include that pancreatitis person as a case, or can I include only the control, or can I include both case and control? Or should I exclude both? What do you think is what is the opinion of the house, or what any?
Both should be excluded, sir.
Pardon, which one?
Both should be excluded.
Very good, very good. I think the controls and the cases should be. If your hypothesis is that both of them are exposed to the thing, when they are not there, both of them should be excluded. Oh, very good. Thank you for answering that properly. So I think I am going in the right direction. Now, there is a study on coffee and cancer of the pancreas. This is a very famous paper which was published in 1981. One day in the morning when the people woke up in the TV news, there was the coffee produces pancreatic cancer. This was published in New England Journal of Medicine. And one of the things was that they found a strong association between coffee consumption and pancreatic cancer. This was a study which was widely criticized. I will go into the criticism of this paper after discussing a certain other thing. These are bombers, bombers which will go and bomb the enemy camp. These are what are called as armors. These are armors which can be fitted on the bombers. So, these armors, when they are fitted on the bombers, will prevent when a bullet hits the plane, if it hits in the armor, it won't damage the plane. So, but you cannot put the armor throughout the plane because the plane will not get up. And so people wanted to find out what is the best place to put the armor so that they can prevent the plane being hit. So I will go tell you a small video. Hope I can clear it.
Hi, my name is Dr. Michael Hausman, and I'm a workforce scientist. One of the things that I often tell people is that before you start analyzing data, it's incredibly important to ensure that you're measuring properly and using the right methodology. Otherwise, you may end up generating spurious conclusions. There's a very simple but powerful historical example that illustrates why this is the case. During World War II, the British were losing a lot of their bombers over Germany, so they decided to add armor to their planes. Now, the armor was heavy and expensive, so they decided that they'd only add it to the parts of the plane that were most critical. Luckily, when planes returned from their bombing runs, they kept meticulous records of where they had been shot. So they were able to take all of these diagrams and superimpose them in order to get a good sense of where the planes were being hit by German anti-aircraft fire. When they did this, there was a very clear picture that emerged. The planes had holes in the wings, the nose, and the tail. So they decided that they would add more armor there. Before they did, however, they brought in an Austrian economist named Abraham Wald, who took one look at the data and said that this is the exact opposite thing that you want to do. The planes they used to generate the diagrams were the planes that had returned from their bombing runs. So the planes that had been shot down were being shot in the two areas that did not have any holes, the body and the rudder. The British added armor to those two areas instead, and thousands of British lives were saved. This is a classic econometric example illustrating the importance of identifying and controlling for selection bias, but there's a broader point to be made. It's critically important to ensure that you're using the right methodology to measure, or you may end up arriving at the exact opposite conclusion.
So I hope, was it clear? Hello? Hello? Was the video clear? Hello?
Yes.
You could understand what was the message I did.
If you have had any doubt, please ask. If you have any doubt about that video, please ask. If anyone having doubts, you can raise your hands.
Sir, could you please explain it after they install the armors on the most frequently hit areas? The center green marked areas were not armored. So
No.
what happened next?
They didn't put the most hit, they didn't put it. Before that, they asked an economist whether they can apply the armor there. But the economist just had a look at it and said that these are the planes which have returned to your country, so they have not been shot down. So he said that those bombers which have been shot down are not reaching here, and so that you have to cover the areas which are not being shown in the plane, which have come back. I don't know whether I made it clear. No, this is a practical example of selection bias, because when the plane came, the areas they were hit, they are the planes which have come back. So the economist said that the planes which have not come back are hit in the place where you are not seeing them. So cover the areas which are not hit. That's what he said. Is it clear?
Yeah, sir. Okay, sir.
Another example, it is called the cat high-rise syndrome. It was found that if a cat falls from a tall building in New York City, they found that a cat which falls from up to the 7th floor, it produces a damage. The cat produces severe damage. If it falls from a floor which is more than 7 or 8 or 10 or 12, then it doesn't harm the cat as much as that one. So they thought that, they gave an explanation that once they reached about the 7th level, the cat used to the height, and then it can slowly come down and land down. So they said that up to the 7th floor, the cat doesn't get it time to balance itself, and that's why the more cats get damaged. So let's hear this one.
There was another study published in 1987 about cats falling from high-rise buildings in New York City. Apparently that was a pretty common thing, which makes sense. A lot of high-rise buildings, a lot of cats. In fact, there were so many that scientists could do statistical analysis on how bad the cat's injuries were depending on which floor they fell from. Now, what was found was basically what you'd expect. The higher up they fell, the worse their injuries. So falling from the 6th floor was worse than falling from the 3rd floor. Totally makes sense. But here's where it gets weird. Beyond the 7th floor, the injuries actually decreased. They decreased a lot. So it was actually better for a cat, say, to fall from a 20th story than from the 6th story. Now, that doesn't really seem to make sense. But scientists hypothesized that what was happening was that cats take about 5 or 6 stories to reach terminal velocity. That speed where they're no longer accelerating because their drag, the air resistance, is equal to their weight. And so beyond that, they're not speeding up anymore, and in fact, they can relax. So if they fall from 10 or 15 stories, they've got some time to relax after reaching velocity, and the theory goes, they land nicely and they bounce and they don't suffer as many injuries as if they fell from a lower height and they were still kind of accelerating as they went into the ground. Now, this theory might be true or might have a bit of truth in it, but survivor bias may also come into play here because, of course, if a cat fell from, say, 20 stories and turned out to be just a splat on the pavement, it would never have made it into the emergency rooms where these statistics were collected. So yet again, we have this clear bias in the data. It would only be cats that had really survived their fall from a high height that would make their way into the data. But survivor bias...
So, is that clear? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
I think what happens to coffee and pancreatic cancer? You know that the study McMahon did was that he took the controls as other patients in the gastroenterology OP or in the gastroenterology ward. So he took without pancreatic cancer. So he took patients from the gastroenterology, divided them into those with pancreatic cancer, without pancreatic cancer, and then saw how much coffee they drank. And they found that if they drank more than 1 cup of coffee a day, there was the odds ratio of 2.75, and was a significant chance of developing pancreatic cancer. But the criticism was that this is a class of selection bias, because people who come to the gastroenterology clinic, many of these people have acid irritation, heartburns, and so on and so forth. And there was even a study which showed that the people who come to the gastroenterology OP take less coffee than the people otherwise. So this is another case of selection bias. So whenever you are taking hospital controls and all, you should look for what is selection bias. And this coffee and pancreatic cancer study was refuted by saying that this is a classical example of a selection bias. You can boldly go home and take coffee. And now there is another thing, which was a study which was done by Bergson. You know that there was increased association between cholecystitis and diabetes. But when the study was done in a hospital, Bergson found that this was not so. Mainly because the people with cholecystitis, when they get pain, they get hospitalized. A lot of people with diabetes get hospitalized due to many other reasons. So the diabetes that occurs in the hospital will be much more than what you see the diabetes in the general population. So because both of these people get to the hospital, you may get a false impression that the diabetes is not a risk factor for cholecystitis. And this is what is called as the big Bergson's bias or Bergson's paradox. And because these two arrows are coming down and colliding, this is also called the collider bias. So when you do a study in a hospital, the population is different, and then the diabetes in a hospital population will be much more than in the general population. So when you do a case control study of cholecystitis with the hospital patients as controls and take diabetes as an exposure, you may not find the required difference between the two groups. Can smoking prevent COVID-19? This is another interesting question that has been posed. Now, you look at this data. In China, 8% of the people in the hospital with COVID were smokers, while 26% of the general population smoke. The equivalent figures in Italy are 8% of the COVID hospitalized patients smoke, whereas 19% of the people in the population smoke. So does it mean that COVID prevents, smoking prevents COVID? Anyone can give an explanation on that? I don't know whether am I clear on that?
Dr. Rajendra Prasad?
Studies show that when in the hospital, only 8% of the people with COVID are smokers. Whereas in the population, 26% of the general population are smokers. So if you do an odds ratio, it will be less than 1, and you may reach a conclusion that smoking can prevent COVID. Any explanations on that? But the theory, it was the example that was given is that it was the younger people who smoke and it is the older people who get admitted. It's the older people who get severe disease and so they get admitted. And the population of smokers in the older generation is not as much as that you get in a younger generation. And that is one of the explanations given for this. I don't know whether I make clearly. So the similar thing of a collider bias can occur here. COVID severity, people may get hospitalized, but the smoking people can get admitted due to smoking due to a variety of other diseases as well. This is also a case of selection bias or a collider bias or a Bergson's bias as it's called. Can I go to the other one? Hello?
Sir, can you explain the collider bias once again? Because collider bias.
Yeah, this is, I think, this explains, people get admitted to the diabetes and its complication makes a person get admitted to the hospital. So if you look at the hospital population, the number of diabetics in the hospital population will be more than in the general population.
Okay.
So, but when you are doing a case control study to see whether diabetes is a risk factor for cholecystitis, you may find that if you do it in the general population, you may find that cholecystitis is a risk factor for diabetes is a risk factor for cholecystitis. But when you compare with the controls in the hospital, the diabetes in the hospital may be much higher and you may not find this difference. And because both of these variables, diabetes and cholecystitis, go for result in hospitalization, that's why it's called collider bias. Am I clear on that?
Okay, sir. So ideally, we should not take in-hospital patient for these studies.
Yeah, we should have all this bias, or we should see that those things are not there. And if you are taking an exposure, like say Ayurvedic drugs, and you should show clearly that the hospital population take the same, the number of people take the Ayurvedic drugs as in the general population. So otherwise, hospital population, there is always a selection bias, like the plane that comes back. It's not the. So this is the collider bias. This is another study which we did in male inflammatory. This is a case control study in which we took the controls. There were cases and controls where we asked the patient, why don't you nominate your neighbor as a control? And so is there any harm in doing that? Sometimes, if you go into a study and the person is in a Lions Club or a lottery club or something, he may ask his friend, why don't you be a control? When you make such controls, they may all be members of the same organization and can create what is called as a membership bias, because the characteristic like smoking, drinking and all may be the same in the two groups. And this is what is called as a membership bias. Now I want one of you to answer this question. Who is the smartest among you? Can you please come up? Hello?
Give a prize for the person who answers first.
Yeah, I think now you see that this is what is called what graph is this one? What graph is?
Forest plot.
Forest plot.
Forest plot. This is called as, I don't know why they call it as a forest plot. There's a famous epidemiologist by name Pito. Pito is a cancer epidemiologist from Oxford, and he once jokingly said that there was a study done in breast cancer by a person called Pat Forrest, and that's why it's called as a forest bias. But no, it is the. So can you, looking at this data, can one of you tell me which of these had the lowest? This is diabetes as a risk factor for severe COVID. Which of these had the largest sample size? Which one of these had the smallest sample size? Can anyone tell me that?
The study with the largest size square.
No, tell me which one is that? Which one?
They won't be able to use the cursor, sir. They won't be able to use the cursor.
Below or above, tell me from. Which is the largest sample size? Can anyone tell me which is the largest sample size?
You can mention the study. Yeah.
So,
yeah. Anyone who can say which is the. No, you look at the.
Go on.
And 14, sir.
14. That is what is that?
14 odd ratio is the largest.
14 odd ratio. Yeah. they look at the confidence interval. Look at your confidence interval becomes narrower and narrower as the sample size increases. Do you understand that? Suppose you are getting an odds ratio of 14. If you are having a very large sample size, the confidence interval will be very narrow. So ideally, can you make one more guess? So the biggest will be
1.10 odds ratio.
Pardon?
1.10 odds ratio.
1.5?
No, sir. 0.25 odds ratio. Wang C et al.
Q.
1.79.
Q 1.49. Now that's a small sample size. That's good. 452. But you see that this is a 1,000. That's a very small size. This also, I think, because there's a very large sample, very small confidence interval, and a very large confidence interval. You look at this one. So I think that you understand the principle of the confidence interval. The larger the sample size, your confidence becomes greater, higher and higher. So it becomes narrower and narrower. And then you see that small squares here. Why the squares are different? Do you know why the squares are different sizes? This is what is called
Power of the study.
This is what is called, for whenever you are doing what is this type of study called when you are doing such a large number of studies and analyze them together? It's called as
Meta-analysis.
Yes, when you cannot give the same weight to all the studies. You cannot give the same weight to a study with 21 and another study with 400. So the weight of the study is determined. That is shown by the square. So the maximum weight is for one and then 2 and all those. So that shows the weight of the study. And do you know what is this? The lower y squared. Do you know what is I squared? I squared shows the heterogeneity in the data. Is the data very bad? Or suppose a lot of people say this diabetes protects you, and a lot of people say that it's a risk factor, and the whole it is heterogeneous means that the I squared will be very high. Here you say that the I squared is below 40%, so the heterogeneity is not that much. So in a meta-analysis, you have to look at what is the I squared, which the lower the I squared, the more reliable is the data because the heterogeneity is not that much. So this is the odds ratio and the confidence interval, weighting, and then can you see which one of these is a non-significant one? Which one of these? Now, can you see whether this is significant? 1.79. Is this significant?
Yes.
Yes.
Because it is above 1.
Above.
So, what about below that?
Very
Below.
it is less than 1.
So, the other one is above 1. So, if it is overlapping 1, it is not significant. You understand that? This is 1. If it is overlapping 1, it is not significant. If the whole confidence interval is here, it's a protective thing. If the whole confidence level here, it's a risk factor. Can I move on? Is it clear?
Yes, sir.
Yes, sir.
That's about odds ratio. So the case control studies allows us to study rare diseases. You can look at multiple risk factors. It can be helpful when outbreaks occur. The investigator can include unequal numbers of case and control to increase the power of the study. But you know that case control study has been recent. This was a paper published from All India Institute of Medical Sciences. There they used the case control study to study the effectiveness of a vaccine. And this is what is called a test negative case control study. They did the study in their institute where they took the employees of the All India Institute, and you can see that there were people who reported to the outpatient who required a RT-PCR to be done. There are 3,100 persons reported RT-PCR done. 1,800 were positive, 1,300 were negative, and they looked at the vaccination data and came out with this study. They found that if you take 2 doses of the vaccine at least 14 days before the test was done, it protected you from getting COVID. So I think even case control study can be used even for the effectiveness of a vaccine. It has been used, and this is what is called as a test negative case control study. Now I think, but one of the best methods to study the effectiveness of vaccine will be cohort study, which I think I'm not going into the detail. A cohort is actually they used in this Roman legion, where they said one legion is equal to 10 cohorts. Cohort means a group of people who share the same characteristics. That's what is called as a cohort. So in a cohort study, what you do is that you follow them over a period of time and you compare the outcomes. You know, we have a group of people with the exposure. In the case control study, you started with the disease. Here you start with the exposure, smokers and non-smokers, follow them over a period of time and see how many of them developed the disease. So we know that case control studies have been called as the
Retrospective.
The case control studies have been called as
Retrospective studies.
Retrospective studies.
It's called Trahawk studies. Do you understand that? Some people call cohort case control as Trahawk study. Do you know why? Because it is cohort reverse. So yes, so this is from exposure to the disease, whereas in case control disease to the exposure. So that's why some people call it. The disadvantage is that an exposure, if a person takes cassava, you have to wait for years for it to develop pancreatitis, so it may not be very prolonged, not good for rare exposures, rare outcomes. It may be inefficient because you have a large number of people and it's maybe very expensive. So now let us come to another interesting data. This shows the COVID mortality rate in different parts of India. You know that for 100 persons, the people who died in Kerala are 0.53, whereas almost 8.3 people have died in Meghalaya. Any explanation for this? Anyone can come boldly forward and give an explanation why this is? Yeah, actually, if you're a politician, you can always boast saying that if I am from Kerala, I can always say that look at the way we are managing COVID and we are doing a wonderful job. And then we have, is there any other statistical explanation for this? Can anyone give me that? Any explanation for this?
Maybe the number of cases tested are different.
Yeah. What is your name?
Kiran, sir.
Kiran, very well done, well done. And that is what is called as the. So this is what is called as this shows the COVID fatality, case fatality rate in COVID and the number of tests that has been done. So the more the number of tests that you do, and the more, and you'll find that your fatality count, this is what is called as an ascertainment bias. The more cases, you go to the field, you get very mild cases, asymptomatic cases, and all are picked up. So when you finally look at the data, mortality, you may think that the management is very good, when in fact it is an ascertainment bias. So when you do more and more, and you pick up more and more people with COVID who are actually walking asymptomatic in the street, you can pick them up. And that may be one of the reasons for, and this is what's called as an ascertainment bias. And it has been shown that the case fatality rates declines almost 20% of each doubling of test density. Ascertainment bias can occur even in cohort studies. Suppose I am doing a study on breast cancer and oral contraceptive use. I have a group of people who are on oral contraceptives and other group who are not on oral contraceptives. A person with who is on oral contraceptives comes to me and says that I feel something in the breast. So so he's on oral contraceptives, so he may be having breast cancer. So you go into a mammogram. But if a person who is in the control group comes and you may say, you may palpate, find nothing, I say no, nothing wrong, go ahead. So the more tests that you do, this is one of the bias that can happen in cohort studies, what's called ascertainment bias. And ascertainment bias may be the responsible for the low mortality that we see in COVID in certain areas. I'm not saying that that is the case. That can be one of the explanations. Yes. Okay. This is a proton pump in a cohort. They found that proton pump users had 9.3% chance of getting ventilated, but non-users it was 7.5%. This has been referred to as channeling bias. Because whenever a person goes to an ICU, you get a lot of medicines. And some people write proton pump inhibitors, invariably they write. For any prescription, they write, like in the Malayalam, there's a saying called kashayam in chuk. I think in Tamil also there is saying like that, is it not? There is no kashayam without a chuk.
Decoction.
Decoction, yeah, there is no so there is no emergency and there is no prescription without PPI. So the more severe, one of the reasons why these people got proton pump inhibitors may be due to reverse causality or channeling bias, and as they are prescribed more proton pump inhibitors. So I think that I will go into the thing. So I think let me now take a case scenario. I want one of you to answer this. I want to do this study the effect of soft drinks on dental health. So I want to give one soft drink a day to a volunteer and study the buccal flora and dental health. So what I do is that I got a lot of postgraduates. I take my gastro PGs and give them a cup of Coke. And cardiology PGs, I ask them not to take Coke. And I give them tea. And after a month, I examine their buccal flora, dental health and all. Any comments on this study? Anyone would like to comment on this study?
Because the exposure is different in these two study groups. One is getting exposed to tea and the other is getting exposed to Coke.
I want to find out the effect of Coke. They are not exposed to Coke. So I think, so that's what I want to find out. Anything wrong? So it's okay, you will agree for this study?
No.
Why not? One of the reasons why
gastro PG is taking tea.
They let them take interest only in Coke. I asked the cardiology PGs not to take Coke. Let them take Coke, tea or anything. I am interested only in the effect of Coke.
Sir, it will be a membership bias since all are PGs only.
So what? So I think one of the things I want to stress here is that this study should not be done. You know what is vulnerable subjects? Because this study is being done in a vulnerable subject. A postgraduate student is susceptible to exploitation, unequal power relation, dependency, and no voluntariness in their consent. So as a boss, I should not do my study on my postgraduate students. And if I do a study on my postgraduate student and you tell me that you are allergic to Coke, and you may say that I'm sorry, I can't participate, I'm a little allergic to Coke. And when the examiner, when an external examiner asks me, what is your opinion about him? I may say that he's a little bit arrogant, I think so. Can I say like that? Would I? So I think one of the things which I wanted to share here is that one should not do a study on their student subject. They are vulnerable study subjects. Vulnerable or special class of subjects include pregnant women, human fetuses, neonates, prisoners, students and employees, children, minorities, cognitively impaired persons, economically, educationally disadvantaged, people with AIDS, or people who are terminally ill. You don't include them under unless special circumstances. Let me do I am doing a study with comparing drug A and drug B. I recruit people and some of them complete the study and some of them are cured. Let us see that 100 people are recruited drug A and drug B. Only 80 people in drug A complete and 60 people in drug B complete. Whereas 64 people in the drug A group are cured and only 48 in the drug B group are complete. Which one is better? What is your opinion? Which drug is better? Which drug is better? Anyone? I give 100. I start with 100 people in two groups. I have randomized them, and 80 people and 60 completed. Any guess on that? Which is a better drug?
Drug A.
Why?
Drug A. Because 80% are cured in drug A group and 70% are cured in drug B group.
60 out of 60, 80 is 48. Yeah. What do you think?
If I do an intention to treat analysis,
Yeah.
A would be better. And
Yeah.
if I do a per protocol analysis, B would be better.
You introduce the term intention to treat analysis. I hope all of you are familiar with this one. Well, I think it is important that we understand by intention to treat analysis, you will find that which one is better, drug A is better. Yeah. So if you do an analysis taking only the people who completed, it violates the principle of randomization. Non-compliance related to the treatment or to the disease severity. Exclusion of, I think so. So I just want to introduce what is intention to treat analysis. Now I introduce one more term, number to treat, number needed to treat. If I give 100 people statins and follow them for 3 years, and at the end of the 3 years, I find that 10 had stroke. 100 were given placebo, followed for 3 years, and I find that 20 had stroke. So by giving 100% statins, I have prevented 10 episodes of stroke. Is it clear? Is it clear? I have got 2 groups of people, one were given statin and the other were given placebo. And at the end of 3 years, I find that in the 100 statin group, 10 people had stroke. And in the other group, 20 had stroke. Can you see the slide?
Yes, sir.
Yes, sir.
Yeah, so can you see that? So by giving statins, I have prevented 10 strokes. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Prevent 1 stroke, how many patients should have been treated?
10.
Eh?
10 patients.
10. Number needed to treat, yeah. If the number of patients so you have a drug with an NNT of 5 and another drug has an NNT of 20, which is a better drug?
NNT of 5.
NNT of 5.
You all know all these things, is it? Is the number of patients you need to prevent 1 additional. The number needed to harm correspond to the number of individuals that must be treated so that one of them presents an adverse reaction. Yeah. This shows the evidence pyramid, and you know that case controls are low down, cohort up, randomized control studies up and up and up. One of the most important things in doing research is that you should have a good knowledge of medicine or good knowledge of gastroenterology. Science is simply the common sense at its best. And I think a person who knows gastroenterology best can do a better research than a person who doesn't know gastroenterology and knows only research methodology. I quote this Mao Zedong often, not because that I like him, but I like his quote. He said that if you want to know the taste of a pear, you must change the pear by eating it yourself. If you want to know the theory and methods of revolution, you must take part in a revolution. All genuine knowledge originates in direct experience. So if you want to know about research, just go ahead and do research. Thank you.
Thank you, sir. Jayanti ma'am. Jayanti ma'am, are you there? I think.
I'm here.
We can allow questions.
I was enjoying the video and the way sir took us through the session. No, wonderful. I was just
People can ask doubts now.
No, I just did I miss something on the Indian cases which have been reported? Maybe because I said about calcium pancreatitis, about the tropical sprue. Is there any other thing which I might have missed? I just
most of the times, as you were mentioning, no, we always have this problem with selection of controls, no, the so-called quote unquote healthy controls.
Yeah.
So that so sometimes we take other members in the family, sometimes we take some people in the master health check.
Yeah.
So, and as you rightly mentioned, someone is taking tea but not Coke, and therefore, so how should we screen the controls? I think especially the case control study, that control has always been a problem with me, and I always get a reply back, no, peer reviewers.
I think the control, in a case control study, we have to see that they don't have the disease. And the next thing is that we should ensure that they are from the same source population as the cases. So if the people are from the same source population as the cases and they don't have the disease, there can be controls. And to adjust for the age and sex, you can match them for age and sex and do a matched analysis. So if the case control should be from the same population and the same source population, and then the control should not have the disease in question. That's all.
Supposing we have to do a case control study, say on metabolic fatty liver, and you want to study the metabolic syndrome, the components. So they all come to the master health check, and we have the ultrasound. One group will have the fatty liver, one group will not have the fatty liver. Is that sufficient, or should we screen them for the components of metabolic syndrome as well?
No, your hypothesis is that what is the risk factor for fatty liver? Is metabolic syndrome a risk factor for fatty liver? So what you do is that if your major variable is metabolic syndrome, you can adjust for all those things. So you can see that take the two groups, one without fatty liver and one with fatty liver, and see the metabolic syndrome. But there may be other variables which you can adjust in the analysis, like family history and things like that, which may interfere with this. You can always adjust for them in the history. And then if you are looking for more than one variable, you say that in the alpha error of 0.05, you should reduce that alpha from 0.05 to point. If you are looking at 5 variables, you look at 0.01. You divide the alpha by 5, the number of variables that you are checking. So that's why you can do it. Yeah. And I think case control studies are one of the easiest studies to do. And I would like to tell the postgraduates that this is the time that you can do research, but because you are supervised by teachers who have got experience in the field, who have made a mark in their field, and you can always come out with a very good study. Don't miss on this opportunity. See that you do a good study and get it published. So I think that, and you may not get a chance like this again. So do a very good, sincere study and get it published. That's what I want to do it.
Sir, I'll just make a comment. I think this is also a time, when you get a passion for research, that's like, for example, I'll take my own self. When I joined for MD General Medicine, I came across Professor Solomon, Victor, Professor Madan Gopal, who had these questions. And I think the bottom line is the passion should come in, why, how, what, and not accept things as and how they appear. Yes. And I find that now what's happening is people have to do research. They have to do a thesis, not research, a thesis. So they come with this quote unquote 50 number, which never gets published. Nothing gets published. I'm going through, so I have to go through other 2 D&D theses now. And now they're saying that due to COVID times, it is being relaxed to the number of cases. And therefore keep that in mind and then correct the thesis. So now the candidate is at an advantage, but he or she is not learning the research aspect of this. I think that while completing all the formalities for your curriculum, I think this is the time, as sir said, that you start developing an interest towards the subject. You've taken a profession as gastroenterologist, you've taken a profession as hepatologist.
I think
that is something that has to come from within, and that we are not finding, sir. It is not there, sir.
Yeah, I think it should come. I think one of the things which I would like to say is that in Trivandrum there is a temple called, you may all know about the Sri Ratmanava Swami temple.
Yeah.
It's supposed to be the richest place in Kerala. But there is a room in the library in Trivandrum Medical College where I find a lot of CDs. The theses of all the PGs are lying there. And if I am asked which is the wealthiest thing in the place in Trivandrum, I would point to the library where many of the theses, the works that PGs have done are lying there idle, unpublished. And
unpublished, yes, that's what I said. They don't, if it's not published.
A student a student is like a donkey carrying a sack of gold. The donkey knows only the weight of the gold, but not its value. But I think, I think that as postgraduate students, please see that you get your thesis published, and I think do a sincere work, and I think it's really enjoyable, and I think the fruits will come to you.
This is just fun. It is fun. It is fun doing research. Actually, that's what it is.
Right.
And Professor Solomon Victor would say, you publish or you perish. Professor Marthan would also say that. And all of us who have done whatever little research work we have done, I've also been always in a public sector like Professor Narendra. But the thing is, we have not done anything to get a name for ourselves. We've not done anything, but we've tried to get some information for patient care, towards patient care. if you can ask me what's esophageal cancer, what's the gallstone type and all, I can tell you everything about Tamil Nadu patients. Because I've got my information about my patients, and it helps me in my patient care. I think that is very important, and all of us who have later on come to be known as so and so is only because of publications. So and so we have all come to the forefront not because of the money that we've earned or the practice that we have established, but it is only the papers and publications, that is only one that, and it is not for name or fame. I think that's something that you should get out of the mind, the PGs.
I think one of the most depressing things I have seen as ethics committee chairman is that when I see the thesis of postgraduates coming for review,
Exactly.
it is in bastards. Many of them, it has been that they cut and pasted it somewhere. You feel sad looking at the research proposal that come from ethics committee, and many of them are, these people are selected, and then all these things in bastards.
Exactly.
I think these have been cut and paste from another.
Exactly. Yeah.
Interesting.
We're not able to get that into the. I'll just tell about myself. I went to UK. I was selected for this one IBD fellowship. It was one of the first time an Indian was. So when I reached there, the people there thought that I'd come for the money. Okay, they thought I'd come for the money. But for me, money was not important, and they didn't realize that I was probing into every aspect of the research work that they were doing. I did not allow them to take an upper hand, and that they were surprised. And towards the end, when I was leaving the place, my boss, he said, we thought that you'd just come for money, but I got 23 papers published in that 1 year instead of just 4 papers. So I think it is, and that was the breakthrough, because it gave me a breakthrough that, okay, we have to stand on our feet, we have to do so-called research and researching what is already there. And I request all the students to develop that passion, that has to come from within you. Even whatever lectures and talks we give, you hand over the data to the statistician. Even I am not good in statistics at all. I love listening, but in a given case, I'm not good in maths. But when the statistician gives me an information, that I can analyze and say you're wrong. And to that extent, at least I'm able to say that you are wrong, and therefore this is what is expected, and where did you go wrong? So my only humble request is all of you who are doing thesis, see that the paper leaves you as a publication before you complete the exam. Very important, very important. Professor Martin, when I was doing my DM, he was very clear. He said that article, the paper that your work that you've done has to be on my table before you enter for the examination hall. Otherwise, you will not be allowed to enter the examination hall. Very clear. And it has to leave for publication. It should be ready for publication. So I think those were the people who really gave us a push and brought us enthusiasm. And we have Professor Narendran, Professor B, all of us, Krishnan, Dr. VT, all of us are just trying to inculcate that into you apart from the usual clinics and examination. Now, please don't read for the sake of examination. This is your future. No one will take so much of interest to develop your future. Whether you're doing endoscopy, yes, you can write papers on that. You're doing liver, you can write papers on that. You can write anything. But you please always have a question why. Don't accept. Don't accept what is given to you. That's the question. Sorry, I've lost my cool.
Any residents, any queries? Any questions you have to ask? This is the best chance.
Or you're doing some thesis and you have a question, you can ask sir straight away now.
Yeah. You will never get this golden opportunity
again. Exactly. Yeah.
And remember, Professor Narendran had the highest number of papers in Kerala when he was a professor. And remember that the facilities to do publishing was very little. It was extremely difficult to publish in those days. Think of something 30, 40 years back.
Yeah.
It was practically impossible. It was an ordinary typewriter with which we used to type.
And white paint.
Black and white photographs. There was no internet. There was nothing. Understand? There was no computer, nothing. Still people are publishing. So Sir has come from that era to this era. Okay, so you know how much difficulty transition has gone, how much difficulty we all had, especially sir, the maximum number of papers when he was a faculty in medical college. And Jayanti ma'am is another example from Tamil Nadu. She also has the maximum number of papers. And I have Dr. Rajesh also listening to us. Dr. Rajesh, please come up. He has also now currently the leading person with a lot of papers from Amrita. Dr. Rajesh is publishing a lot of papers, especially pancreas. He has the blessings of Balashtan sir. Narendran sir also had the great opportunity to work with Balashtan sir.
Dr. K.T. Shenoy, you have a lot of people.
Yeah, K.T. Shenoy was with us. So I think what Narendra sir, what Jayanti ma'am said is that I also used to stress or rather pressurize my PGs to publish it. And in fact, from 2000, until 2010, I had almost all papers got published. But after 2010, the number of PGs started increasing, and it was a sort of, you are not publishing, I am not publishing, so we are all happy, that attitude. Okay, till then it was 1 or 2 students, they used to agree, and after that nothing. And some of the studies I could not publish, wonderful studies they did, but the number of patients are less. For example, even now every day I am repeating the study, that is simulated driving in persons with the liver disease, decompensated liver disease, in a simulated driving, and whether they pass the test. Okay, and this test right now I am doing. This was completed 3-4 years ago by one of my PG, but still could not publish it because the numbers are less. Because I just completed 20, and with 20, if I send, probably it will not get published. That's the main issue. The numbers will have to be there. As Narendra said, the numbers give the power. Any questions, please?
My email there. If anyone wants to, any postgraduates, you are welcome to share your thoughts with me. I think any feedback on this, both negative and positive on this class will also be welcome. So I have given my email there. The postgraduates, if you are interested, you are welcome to share your thoughts with me. Thank you.
Thank you so much, sir, for sharing the email. I'll start sending information, requesting you to help me out. Thank you, sir.
If there are no further questions, we will close the session. We are coming to 9:28. Dr. Srividya, for the formal vote of thanks.
Yes, sir. Respected faculties and my dear friends, and I would like to extend my sincere thanks to Narendra sir for simplifying the statistics so that we can understand it very much. And also, I would like to thank Jayanti Madam and Varghese sir for contributing this class. And I would also like to thank students and Sun Sickness for participating and supporting us. Thank you.
Thank you, sir. Thank you very much. It was a great session.
Thank you.
I am sure our students are greatly benefited. There's no doubt about it. We have covered a lot today.
And they answered also well.
Yeah. We expect a further session with you, sir.
Thank you, sir.
Thank you, sir.
Good night.
Good night. Good night. Good night.